Good morning, everyone. Today's lecture is about dynamics practice exam. Some of the slides are taken from this book, Vector Mechanics for Engineers. Okay, talking about motions. Motion could be rectilinear. Then we're going to talk about position, velocity, and acceleration. Rectilinear motion, if particle moving along a straight line, we call it rectilinear motion. Position coordinate defines by positive or negative distance from a fixed origin on the line. The motion of a particle is known if the position coordinate for particle is known for every value of time. So we can express that in a form of a function. Basically, derivative of distance is velocity. Derivative instantaneous velocity is when the delta x over delta t, the limit of that goes to delta t goes to 0, then we have velocity. That's instantaneous velocity. It could be positive or negative. Same way for instantaneous acceleration, which is the limit of dv over dt when dt goes to 0. Instantaneous velocity may be positive or negative again. As an example, if you have a function, for example here, x equals ct squared minus t cubed. If you take the derivative of x, you get velocity. If you take derivative of velocity, you get acceleration. And on the opposite direction, if you take the integration of acceleration, you get your velocity, and take the integration of velocity, you get your distance. Question: what is true about the kinematics of a particle? The velocity of a particle is always positive. No, it could be negative. The velocity of a particle is equal to the slope of position time graph. Exactly. So slope is dy over dt, dx, which would be in here, for example, this is velocity versus time. So dv over dt, that's your acceleration. So the slope of that would be your, the velocity of a particle is equal to the slope of a position time graph. Same way for slope of a velocity versus time gives you acceleration. Okay, so number B. X equals ct squared minus t cubed. Take the derivative, get the velocity, and we take the derivative again, get the acceleration. And if you look at these three plots, first one is x versus t, second one velocity versus t, and third one is acceleration versus t. What are x, v, and a at t equals 2? So basically this is time. At t equals 2, we can find position. X is 16, velocity is 12 meter per second, and acceleration is 0. Just by looking at the plots. Any questions? All right. Okay, this table gives you kind of a summary of kinematic relationship. If acceleration is function of time, then dv over dt is acceleration. So this is just the summary that we just talked about. You can refer to it as needed. Any question about this slide? Yes?
What is the equation for end of the bottom? D, dv, dx left side?
Which one? This one, if acceleration as a function of velocity.